Good morning. I am Venkata Rao, Professor of Mechanical Engineering, IARE, Hyderabad. Today, I am discussing about the topic Simplex method. Simplex method is the popular method for finding out the solution of linear programming problems. Linear programming is the linear programming deals with the optimization of objective function subject to a set of linear set of inequations or equations known as constraints. The objective function may be profit or production capacity. The restrictions may be on the raw material, storage capacity, and etc. When the decision variables are more than 2, the simplex method is very useful. The simplex method is a iterative algorithm. It consists of systematic procedure and involves generating series of solutions in a table. That means in each table one solution will be there, so we can improve the solution from table to table until we will get an optimum solution. First, we have to check up whether all the right side constants of the constraints are positive or not. For example, the equation is 2x1 plus 3x2 is less than or equal to minus 2. So if that is the case, in that case we have to convert that one into positive. How? By multiplying the entire constant by negative side. Then minus 2x1 minus 3x2 should be greater than or equal to 2. That means if all the right side constants of the constraints are positive, if any one is negative, that should be converted into positive. Next, convert the inequality constraints into equations. So, inequality constraints into equations. For example, 2x1 plus x2 is less than or equal to 5. So, it is an inequality having less than or equal sign. Now, convert that one into an equation by introducing slack variables. The variables which are used to convert inequality constraints into equations when the constraints are having less than or equal sign are called as the slack variables. Now 2x1 plus x2 plus s1 is equal to 5. So this s1 is called as the slack variables. The coefficients of these slack variables are zeros in the objective function. So after converting the constraints into equations, then write the objective function and then write the and construct the starting simplex table. Next, determine the values of the basic variables in starting simplex table. The non-basic variables are zeros in the starting simplex table. So now the equation is 2x1 plus x2 less than or equal to 5. Now it is converted into a equation. So 2x1 plus x2 plus s1 is equal to 5. In the starting simplex table, non-basic variables x1, x2s are zeros. When x1, x2s are zeros, then you will get the value of basic variable s1 is equal to 5. Like that, we can find out the values of the basic variables. These values should be entered in the table. Next, calculate the values of z and delta. Z is equal to CB XB. That means coefficients of basic variables and values of the basic variables. If you multiply that, you will get the Z value. Then we have to find out delta value. Delta value is equal to CB XJ minus CJ value. Now you can see the table. Now this is the simplex table. In this table, the first column is the basic variables. The second column is CB XB. CB means coefficient of the basic variables. XB is the values of the basic variables. X1, coefficients of X1 in the objective function. X2, coefficient of variables in the objective function. And X3, coefficient of X3 in the objective function. And S1, S2, S3, the corresponding coefficients in the objective function. The CJ values are given. CJ is equal to coefficients of variables in the objective function. So, x1 coefficient is 3, x2 coefficient is 2, and x3 coefficient is 5, s1 coefficient is 0, s2 coefficient is 0, and S3 coefficient is 0. Also, like that we have to fill the simplex table. Now, so after calculating the values of Z and delta, we have to test whether all the Z values are positive or all the delta values are positive or not. If all delta values are positive, the solution will be optimum. If any one is negative, then we have to improve it in the next step. If delta is negative and corresponding values in the key column are zeros or negative, then the solution is unbounded. Next, for improving it, we have to determine the incoming vector. The incoming vector is decided based on the most negative value of delta, and the outgoing vector is decided by the minimum ratio rule. The minimum ratio rule is xb by xk. So the corresponding values of xb by the corresponding values in the key column. Then we have to find out the key element. The element at the intersection of the incoming vector arrow and outgoing vector arrow is called as the key element. If the key element is other than 1, then divide that entire row by the key element in order to make the key element is equal to 1. Next, we have to make all the values in the key column are 0 except the key element. For that, we have to do various row operations. So, again, calculate the delta values, then repeat the steps 6, 7 and 8 until optimum solution is obtained. Now, consider the problem. Z max is equal to 3x1 plus 2x2 plus 5x3 subject to the constraints x1 plus 2x2 plus x3 less than or equal to 430 and 3x1 plus 2x3 less than or equal to 460, x1 plus 4x2 less than or equal to 460 and x1 comma x2 greater than or equal to 0. The first step is we have to check up whether all the right side constants of the constraints are positive or not. In this case, all the right side constants are positive, so we need not convert it into positive. Now, convert the inequalities into equations. The first constant is having less than or equal sign. So, we have to introduce the slack variable. I already told slack variable is the variable which is used to convert the inequality constraints into equations when the constraints are having less than or equal sign. Now, the first constraint can be converted into equation as x1 plus x2 plus x3 plus s1 is equal to 430. Then the second constraint is 3x1 plus 2x3 plus s2 less than or equal to 460. x1 plus 4x2 plus s3 is less than or equal to 420. This is 420. So we have to write this is 420. After converting inequality constraints into equations, then we have to write the objective function. The coefficients of the slack variables are zeros in the objective function. Then the objective function becomes Z max is equal to 3x1 plus 2x2 plus 5x3 plus 0s1 plus 0s2 plus 0s3. Now you can see this in the next slide. Now you see Z max is equal to 3x1 plus 2x2 plus 5x3 plus 0s1 plus 0s2 plus 0s3. x1 plus x2 plus x1 plus 2x2 plus x3 plus s1 is equal to 430. 3x1 plus 2x3 plus s2 is equal to 460. x1 plus 4x2 plus s3 is equal to 420 and x1 comma x2 comma x3 comma s1 comma s2 and s3 greater than or equal to 0. Now here Cj is the coefficients of the variables in the objective function, Cb is the values of the variables in the objective function. Now determine the values of basic variables. So the non-basic variables values are zeros in the starting simplex table. Now, when x1, x2, x3 are zeros, then you are getting s1 is equal to 430, x1, x3 are zeros, then s2 is equal to 460, and x1, x2 are zeros, s3 is equal to 420. So these are the values corresponding to the basic variables. Now you see s1 is 430, s2 is 460, and s3 is equal to 420. So enter these values in the table. S1, the basic variables in the starting simplex table, you can write S1 is equal to 0. The coefficient of basic variable CB corresponding to S1 is 0, S2 is 0, S3 is equal to 0. Then XB values. So already we calculated SB values when x1, x2, x3 are zeros. S1 is equal to 430, S1 is equal to 430, and S2 is equal to 460, and S3 is equal to 420. Now write the coefficients of x1, x2, x3, s1, s2 in the first constraint. That is x1 plus 2x2 plus x3 plus s1 is equal to 430. x1 coefficient is 1, x2 coefficient is 2, x3 coefficient is 1, and s1 coefficient is 1, s2 coefficient is 0, s3 coefficient is 0. From the second constraint, you can write x1 coefficient is 3, x2 coefficient is 0, x3 coefficient is 2, then S1 coefficient is 0 because not there in the equation. S2 coefficient is 1. S3 is not there, so we can take it as 0. Then corresponding to the third constraint, x1 coefficient is 1, x2 coefficient is 4, and x3 coefficient is 0, s1 coefficient is 0, s2 coefficient is 0, s3 coefficient is 1. Now we have to find out the values of z. Z is equal to CBXB. That means 0 into 1, so 0 into 430 plus 0 into 460 plus 0 into 420. That value is equal to 0. Then delta values, that is CBXJ. That means first corresponding to the first column, xj is equal to x1, that is 1. 0 into 1 plus 0 into 3 plus 0 into 1 minus of Cj. Cj value is 3, so that you will get delta 1 is minus 3. Next, we have to find out corresponding to the second one. The second one, CBXJ, 0 into 2 plus 0 into 0, 0 into 4. The value is again 0, minus of Cj is minus 2. Then x3, 0 into 1 plus 0 into 2 plus 0 into 3 is equal to 0, and Cj value is 5, so that you are getting minus 5. So now the delta values corresponding to the S1 is 0, and here also 0, here also 0. Now the most negative delta value is minus 5, that is corresponding to the column x3. Now we have to decide the incoming vector. The incoming vector is corresponding to most negative value of the delta. So the most negative value is minus 5. So x3 is the incoming vector. So that is marked by arrow here. Then we have to decide the outgoing vector. The outgoing vector is decided by the minimum ratio xb by xk. So the key column is 1, 2, 0. So xb values are 430, that is 430 by 1, that is equal to 430. Then second one, 460 by 2, that is equal to 230. Then so in the third row, the value of xk is 0. So when xk values are zeros or negative, we should not consider, because when it is 0, the value becomes infinitive. When it is negative, there is no meaning for it. That's why we need not calculate the minimum ratio, put a dash here. Now the incoming vector is minus 5. Outgoing vector is decided by the minimum ratio. So now you are getting 230 is the minimum. The corresponding element is S2. So S2 is the outgoing. So this is represented by a downward arrow here you can see. And the incoming vector is X3. Outgoing vector is S2. Now that is represented here. So the first row 0, 430, 1, 2, 1, 1, 0, 0. Second row 0, 460, 3, 0, 2, 0, 1, 0. And third row 0, 420, 1, 4, 0, 0, 0, 0, 1 dash. So the minimum ratio is 230. So what is the key element here? The key element is corresponding to the intersection of the incoming vector arrow, that is corresponding to the minus 5, outgoing vector arrow, that is corresponding to the 230. So these two lines are meeting at the point 2. So 2 is the key element. Now the key element is other than 1. So divide that entire row by 2 and write that one in the second row in the next table. That is incoming vector is X3. Outgoing vector is S2. That means S2 must be replaced by X3. So first write that row. So here S2 coefficient X3 coefficient in the objective function is 5. Corresponding to the CB, you write 5. And XB value is 430 by 2, that is 230. Then, so here the values are, this is the key row. That entire row should be divided by 2. 460 by 2, 3 by 2, 0, 2 by 2, 0, 1 by 2, 0. So that entire row is written here. So the row is 5, 230, 3 by 2, 0, 1, 0, 1 by 2, 0. That is the second row. Now we have to make all the elements in the key column are zeros. So first we have to make the first element is 0. For that we have to do the operation R1n, that is new R1 is equal to R1 minus 2R1. So R1 minus R1. You can write this one is, this is 0, 1 minus 1. Here 1 is there. So we have to do that one R1 minus R2n. So that means second row. Second row is 1. 1 minus 1 is 0. So the first row the element is 1 and key row the element is 1. So do the operation R1 minus R2. That means second row we are subtracting from the first row. So for the first element is here 1 minus 3 by 2. 1 minus 3 by 2 is minus half. Then the second one is 2. 2 minus 0 is 2 only. And third row 1 minus 1 is 0. And here 1 minus 0 is 1. 0 minus half is minus half. So that is corresponding to the first row. So first row operation is R1 is equal to R1 minus R2. That is new R2. Then coming to the third row. So third row the corresponding element is 0. So you need not do any operation. So that you can write that row as it is. Now that row is 0, 420, 1, 4, 0, 0, 0, 1. Now again we have to find out Z and CB delta values. Z value is CB x Z is equal to CB xB. So 0 into 200 plus 5 into 230 plus 0 into 420. The total value Z max is equal to 1150. Then we have to find out delta values. Delta is equal to CB xJ. CB value 0 into minus half, 5 into 3 by 2 and 0 into 1 minus of 3. So 15 by 2, that means 7.5 minus 3 is 4.5. Then coming to the second column, the values are 0 into 2 plus 5 into 0 plus 0 into 4, 0 and minus of Cj, that is 2, that is minus 2. Then corresponding to the third one, this is 0 Cb x3, 200 into 0. So Z is equal to Cb into 0, that is 5 minus 0 into 0, 5 into 1 is 5, 0 into 0, so that 5 minus 5 is 0 here. Next, corresponding to the S1, this is 0 into 1, 5 into 0, 0 into 0, that becomes 0. Then 0 into minus half, 5 into half, 0 into 0, the value is 5 by 2. So now see the delta values. So corresponding to the first column positive, corresponding to the second column negative. So the most negative delta value is minus 2. This is deciding the incoming vector. In this stage, the incoming vector is x2. Now we have to find out the outgoing vector. The outgoing vector is decided by the minimum ratio. Now calculate the minimum ratios corresponding to this key column x2. So 200 by 2 is 100, and 230 by 0 we should not consider. 420 by 4 is equal to 105. So the minimum ratio is 100 and the incoming vector is x2, outgoing vector is s1. Outgoing vector is s1. This is represented by a downward arrow and incoming vector is represented by a upward arrow here. Now we have to improve that one again. Now you see that x2 should be, s1 is replaced by x2, and what is the key element here? The key element here is 2. So divide that entire row by 2, that is 200 by 2 minus 1 by 2 by 2 and 0 by 2, 1 by 2 minus 1 by 2 by 2, 0 by 2. So that you are getting the values as here you can see the values, that is 100 minus 1 by 4, 1, 0, 1 by 2 minus 1 by 4, 0. Now we have to use this row and you have to make the elements in that column are zeros. In this column, second row is 0, so you can write the second row as it is. So you can write the second row as it is, that means 5, 230, 3 by 2, 0, 1, 0, 1 by 2, 0. But third row is concerned, it is having 4. We have to make this one is equal to 0. For that, we have to do the operation R3 is equal to R3 minus 4 times Rn. Why? Here 4 is there, here 1 is there. So we have to make this element is equal to 0. For that we have to do the operation R3 minus 4Rn. So here 1 is there, so that here 1, 4, 0, 0, 0, 1. We have to make 4 is equal to 0. For that we have to do the operation R3 minus 4R1. So 4 minus 4, this becomes 0. Like that we have to calculate the values here. Now you see, after deducting, after using that operation, we are getting xb is equal to 20, x1 corresponding to that, this is 2, this is 0, this is 0, this is 2, this is 1 and this is 1. Now again we have to find out z value. Z value is equal to cb xb. 2 into 100 plus 5 into 230 plus 0 into 20. So the total value is 1350. Then corresponding to the x1, the value is 2 into minus 1 by 4, 5 into 3 by 2 plus 0 into 2 minus of 3. So that you are getting this value is equal to 4. In the second column, 2 into 1 plus 5 into 0, 0 into 0 minus of 2 means 0 we are getting. So here 2 into 0, 5 into 1 and 0 into 0 we are getting 0. 5 minus 5 is 0 here. Then here 2 into 1 by 2 is 1, 5 into 0 is 0, 0 into 2 is equal to 0. Here you are getting the value is 1. But here 2 into minus 1 by 4 is half, 5 into 1 by 2 is 5 by 2 and 0 into 1. So that you are getting the delta value is 2 here. Corresponding to the S3, 2 into 0, 5 into 0, 0 into 1 is equal to 0. So that you are getting the value is 0. Now you see all the delta values are positive. The solution is optimum. Then what is the solution? Z max is equal to 1350. So x1 is not there in the table, not there in the basic variables column. So x1 is equal to 0. And x2, corresponding to x2, the xb value is 100. That means x2 is equal to, x2 is this value. Then x3 is corresponding to this value. That is x3 is 230. S2 is equal to 20. Now the value of z, you can find out the z value like this. Z max is equal to, what is the function? We have to consider the given function and substitute here. So then you will get the solution. Once again you can check up. So what is the value here? 3x1 plus 2x2. 3x1 plus 5x2 plus 3x1 plus 2x2. x2 plus 2x2 plus 5x3. 5x3 plus 0s1 plus 0s2 plus 0s3. So you can substitute the values of x1 is equal to 0, 3 into 0 plus 2 into x2 is 100 plus 5 into 230 plus 0 plus 0 plus 0. So the total value is 200 plus 1150. So that is equal to 1350. So this is the solution for this. So that means directly you can read the values of x2, x3, x1 in the column itself corresponding to xb. So the optimal solution z max is equal to 1350 and x1, x2, x3 values are 0, 100 and 230. Next. Now we can discuss about the big M method. Big M method is a variant of simplex method. This is used when the variables are more than 2 and when the constraints are having equal sign or greater than or equal sign, then we cannot use straight away the simplex method. Some modification is here. So here what is that? We will discuss. So it is also an iterative algorithm and it consists of systematic procedures. It consists of a systematic procedure and involves generating series of solutions in the table. So that means the solution is improved by table here. So when the constraints are having equal sign, suppose 2x1 plus 3x2 is equal to some 5. In the starting simplex table, the non-basic variables are zeros. That means x1 comma x2s are zeros. When x1, x2s are zeros, there is no meaning for this equation. In that case, we have to introduce a variable called as the artificial variable. That means 2x1 plus 3x2 plus a1 is equal to 5. Then where x1, x2s are zeros, then a1 is equal to 5. We are getting some value corresponding to a1. This a1 is called as the artificial variable. These artificial variables are having no meaning, but these can be eliminated in the objective function after finding the solution whenever they become zeros. Suppose 2x1 plus 5x2 is greater than or equal to some 5. In that case, when x1, x2 are, so when the constraint is having greater than or equal sign, first of all we have to convert that one into an equation. For that we have to introduce slack variable or surplus variable. So when the constraint is having less than or equal sign, we have to use slack variable. When the constraint is having greater than or equal sign, we have to use surplus variable. Now this becomes 2x1 plus 5x2 minus s2 is equal to 5. So in the starting simplex table, the non-basic variables are zeros. That means x1 is equal to 0, x2 is equal to 0. When x1, x2 are zeros, s2 is minus 5. We should not consider the values, negative values. So in order to get a positive solution, again we have to introduce a artificial variable in order to get the positive values. So we can introduce a variable a2 here. So like that we have to convert the inequalities into equations. Now consider the problem. Z minimum is equal to 2x1 plus x2 subject to the constraints. 3x1 plus x2 is equal to 3, 4x1 plus 3x2 greater than or equal to 6, x1 plus 2x2 less than or equal to 4, and x1 comma x2 greater than or equal to 0. First, when the given function is minimization, that should be converted into maximization. How to convert the function into minimization into maximization? Multiply that entire constraint by negative sign. That means minus z minimum is equal to minus 2x1 minus x2. So the objective is converted. Minus z minimum, you can write it as z max. So z max is equal to minus 2x1 minus x2. That is the first step we have to consider. The second one is we have to convert the inequalities into equations. So the first one, anyhow, it is an equation. You can write 3x1 plus x2 is equal to 3. And second equation, 4x1 plus 3x2 minus s2 is equal to 6. And x1 plus 2x2 minus s3, this is first one, you can consider it as s1, then this is s2 is equal to 4. S2 is equal to 4. So when S1, S2 are, when the starting simplex table, the non-basic variables are zeros. When x1 is equal to 0, x2 is equal to 0, you are getting s1 is equal to minus 6 and s2 is equal to minus 4. The s1, s2 values must be positive only. So for that, again we have to introduce the artificial variable. In the first equation also, when it is having equation, when x1, x2 are zeros, there is no meaning for it. So we have to introduce the artificial variable in order to test it for optimality. So 3x1 plus x2 plus a1 is equal to 3. The first constant becomes like this. The second one, 4x1 plus 3x2 minus s1 plus a2 is equal to 6. x1 plus 2x2 minus s2 plus a3 is equal to 4. When x1, x2 are zeros, a1 is equal to 3. When x1, x2, s1 are zeros, a2 is equal to 6. When x1, x2, s2 are zeros, a3 is equal to 4. So the coefficients of these artificial variables are minus m in the objective function. So that you can write the objective function z max is equal to minus 2x1 minus x2 0 s1 plus 0 s2 0 s1 plus 0 s2 minus ma1 minus ma2, because the coefficients of the variables of artificial variables are minus m, where m is the largest positive value. So in the final solution, the m1 m2 should not be exist. That's why we are taking m is the largest positive value. Now here the equations are converted, the inequalities are converted into the equations. Now the equations becomes 3x1 plus x2 plus a1 is equal to 3, 4x1 plus 3x2 minus s1 plus a2 is equal to 6, x1 plus 2x2 plus s2 is equal to 4, and x1 comma x2 comma x3 comma s1 comma s2 s1 a1 comma a2 greater than or equal to 0. This is the constraint. Now write the objective function and the constraints. So z max is equal to minus 2x1 minus x2 0 s1 plus 0 s2 minus ma1 minus ma2, subject to the constraints 3x1 plus x2 plus a1 is equal to 3, 4x1 plus 3x2 minus s1 plus a2 is equal to 6, x1 plus 2x2 plus x2 plus, so now x1 plus 2x2 plus s2 is equal to 4. Now, so this is the equation. Now construct the starting simplex table. In a starting simplex table, the values of x1, x2, x3 are zeros. So now substitute the values of x1, x2. When x1 is equal to 0, x2 is equal to 0, you are getting a1 is equal to 3. When x1, x2 are zeros, you are getting x1, x2, s1 are zeros, you are getting A2 is equal to 6 and x1, x2 are zeros, we are getting A2 is equal to 4. Enter these values in the table. Now, you see here, A1, this is the objective function. First write the Caesar values. Caesar values are coefficients of variables in the objective function. -2, -1, 0, 0, -m, -m. So the same thing is written here. Next, A1 coefficient in the objective function is -m. A2 coefficient is -m. S2 coefficient is 0. Next, XB values. When x1, x2 are zeros, you are getting A1 is equal to 3. A1 is equal to 3. A2 is equal to 6. S2 is equal to 4. Now, the x1, x2 coefficients and S1, S2, A1, A2 coefficients in the corresponding equations are x1 coefficient is 3, x2 coefficient is 1, S1 coefficient is 0, S2 coefficient is 0, A1 coefficient is 1, A2 coefficient is 0. Then, say in the second equation, x1 coefficient is 4, x2 coefficient is 3, S1 coefficient is -1, S2 coefficient is 0, A1 coefficient is 0, A2 coefficient is 1. And in the third equation, x1 coefficient is 1, x2 coefficient is 2, S1 coefficient is 0, S2 coefficient is 1, A1 coefficient is 0, A2 coefficient is 0. So these are the values we obtained in the starting simplex table. Now we have to find out the z value and delta values. Z value is -m into 3, -3m plus -m into 6, -6m, so that it is -9m. So the same thing is written here, z is equal to -9m. Then corresponding to the first column, -m into 3, -m into 4, that is -7m, minus of -2 is +2, -m plus 2, corresponding to the delta value in the first column. In the second column, -m into 1 plus -m into 3, that is -4m, minus of -1, that is minus of -1, that is +1. Then S1 coefficient. So -m into 0, -m into -1 is +m, minus of 0 is m here. Here corresponding to the S2, -m into 0, -m into 0, 0 into 1, that is 0 here. Then corresponding to the A1, -m into 1 is -m, -m into 0, 0 into 0, minus of -m is +m, -m plus m will be cancelled, so that we are getting 0 here. Corresponding to the A2, again -m into 0, -m into 1, 0 into 0 is -m, minus of -m is +m, so that it becomes 0. Now we are having the delta values as -7m plus 2, -4m plus 1, m 0 0 0. If all delta values are positive, solution is optimum. But here two negative values are there. So in that we have to select the most negative value. The most negative value is -7m plus 2, because m is the largest positive value. Suppose m is 1000. This is -7000 plus 2. This is -4000 plus 1. So that in that the most negative is this. So this is marked by an arrow here. That means this is indicating that it decides the incoming vector, that is x1. x1 is the incoming vector. Now we have to decide the outgoing vector. How to decide the outgoing vector? We have to find out the minimum ratio. So minimum ratio corresponding to this column, that is 3 by 3, that is 1, 6 by 4, that is 1.5, then 4 by 1 is equal to 4. The minimum ratio is here. So the key row is, the first row is the key row, first column is the key column, and the key element is 3. Now divide that entire row by 3 in order to get the in order to make the key element is equal to 1. Now here -m 3 3 1 0 0 1 0. Here -m 6 4 3 -1 0 0 1. 0, 4, 1, 2, 0, 1, 0, 0 is this one. So we decided the first row is the key row and first column is the key column and the key element is 3. Now divide that key element by 3. You write here. So here A1 is replaced by X1. X1 coefficient is minus 2. So here this will give us the X1 coefficient. X1 coefficient is minus 2. 3 by 3 is 1. 3 by 3 is 1. And 1 by 3, 0, 0, 1 by 3, 0. Now we have to make this one is equal to 0 and this one is equal to 0. For that you do the row operation R and R2n, that is the second row, is equal to R2 minus 4 times of R1. So R2 is equal to 4, R1 is equal to 1. So R2 minus 4 times R1. Then this becomes, this element is equal to 1. So 1 minus, this is second row we want. Second row, this element is equal to 6 minus 4 times of this. 6 minus 4 is 2 here. Again 4 minus 4 is equal to 0 here. 3 minus 4 times of this one. 3 minus 4 by 3, that is 5 by 3. And minus 1, minus of minus 1, this is 0. So that it is 0. It is minus 1. Then this is 0 only. This is minus 4 by 3. This is 1. Like that we calculated the values. Then next one is, we have to make this one is equal to 0. For that you do the operation. The third row, new third row is equal to R3 minus R1. So what is R3? So this value is 1. 1 minus 1. 1 minus 1 is equal to 0. 1 here 2 minus 1 by 3, that is also equal to 5 by 3. 0, this is 0, this is 1, minus 1 by 3, this is 0. So that you are getting the values. Now again we have to find out the Z values and delta values. Now you see here, minus 2 into 1 is minus 2, minus m into 2 is minus 2m. So minus 2m minus 2. So now it is modified. You can see initially Z is equal to minus 9m. Now it is Z is equal to minus 2m minus 2. Now we have to find out the delta values corresponding to this entire row. Now corresponding to the first column, minus 2 into 1 into 1 plus 2 into 0, 3 into 0. So this value is CB minus delta value is CBXJ. CB value is minus 2 and this value is equal to 1, minus 2 into 1, and this is minus m into 0, 0 into 0. So that minus 2 plus 2 becomes 0. Then coming to this, minus 2 by 3, minus 5m by 3, minus of minus 1. That 1 minus 5m by 3 is the value here. Here the value is 0 into minus 2, minus m into minus 1 is plus m, 0 into 0, and this value is m. M minus of this is 0 only, m only. So that this value is m. Then coming to this value is minus 2 into 0, minus m into 0, 0 into 0, minus of 0 is 0. So now here minus 2m into 1 by 3, minus m into minus 4 by 3, 0 into minus 1 by 3. This becomes 4m minus 2 by 3 and this becomes 0. Now you see, one is 1 minus 5m by 3, another one is m, another one is 0, another one is 4m minus 2 by 3. So the most negative is this one. So this will decide the incoming vector. The incoming vector is x2. Now we have to decide the outgoing vector. The outgoing vector is decided by the minimum ratio. So we have to calculate the minimum ratios by using the key column. The second column is the key column. The ratios are 1 by 1 by 3, that is 3, 2 by 5 by 3 is 6 by 5, 3 by 5 by 3 is 9 by 5. So in this the minimum ratio is 6 by 5. That means second row is the key row and second column is the key column. So the key element is 5 by 3. The key element is 5 by 3. Now divide this key row by this element 5 by 3 and enter in the next table. And we have to make this element is equal to 0 and this element is equal to 0. Now you see, so this entire row is divided by 3 by 5. X2 coefficient is -2 and this is divided by, so this is divided by 5 by 3. 2 by 5 by 3 is 6 by 5. This is 0. Minus 1 by 3 by 5 by 3, 0 by 5 by 3, minus 4 by 3 by 5 by 3, 1 by 5 by 3. So when divide that one, you will get the values as -2, 6 by 5, 0, 1, minus 3 by 5 and 0. So you need not calculate the values of A1, A2 whenever they becomes eliminated. So when A1, A2s are eliminated from the table, you need not calculate the values of delta values. So whenever it is replaced, you can remove those values, then you need not calculate the values. Now we have to make the first row element is 0 and third row element is 0. For that we have to do the operation. The first row R1 minus R2. Now you see here the element is, the key element is this. So we have to make this one is equal to 0 and this one is equal to 0. For that you do the row operation, and so here you can do this, and similarly for the third row you can do like this. Then you will get the values are 0, 0. You can get this is 1, 0, 1 by 5, 0. Here 0, 0, 1 by 1, 0, 0, 1 by 5, 10. So here delta values are positive, the solution is optimum. So you are getting Z max is equal to minus 12 by 5. Z max is equal to minus 12 by 5 and x1 is 3 by 5, x2 is 6 by 5 and s2 is equal to 1. So this is the solution, but we want to find out the minimization problem, so that you are getting, again multiply by this by negative sign, then it becomes Z minimum is equal to 12 by 5, x1 is equal to 3 by 5 and x2 is equal to 6 by 5 and s2 is equal to 0, s2 is equal to 1. This is the solution. Now like this you can find. Now you see all the delta values are positive. The solution is optimum. So now we have to see this one. So first we have to calculate the Z value by using the relation CBXB. Then we have to find out the delta values. So the delta value can be find out by using the relation CBXJ. So CB values are here. CB is -2, this is 1 by 3, like that. Minus M, minus 5 by 3, 0, 5 by 3. Like that we have to find out. And finally we have to see whether all the delta values are positive or not. If all delta values are positive, the solution is optimum. If any one is negative, then the solution has to be improved. So finally we calculated the Z max value. Z max value is minus 12 by 5 because this simplex method is used for finding out the maximization. But when the problem is given minimization, that cannot be solved. How? By first that should be converted into maximization, and then we can find out the solution. After getting the solution, again we can convert that into minimization. So that's why that is the way to find out the solution of linear programming problems. That means when the constraints are having less than or equal sign, we can use the simplex method straight away. When the constraints are having equal sign or greater than or equal sign, then we have to use the bigger method. Why we have to use the bigger method? When the constraints are having greater than or equal sign, then we have to introduce the artificial variables. Why we have to introduce the artificial variables? When surplus variables are used, then we are getting negative values. So we should not consider the negative values. We have to make them surplus variables are zeros. Whenever we want to make surplus variables are zeros, we have to introduce the artificial variables. So when the artificial variables are there, then we must go for the bigger method. Bigger method is used only when the constraints are having equal sign and greater than or equal sign. When equal sign also, it is not possible to obtain the starting solution in the starting simplex table, because when it is having equal sign, there is no meaning when x1, x2s are zeros. Okay, this is the way to find out the solution of linear programming problems by using the simplex method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.